Hi everyone, Nicola from JetScale AI. I'm joined this morning by one of our founder engineer, Marwan.
Thanks for having me.
Thank you for being here today, Marwan. I want to discuss some concrete recommendation in JetScale AI. Some of them are very complex, and I would like to just understand them today.
Yeah, for sure.
Let's start with VM. A lot of clients come with questions about clusters of machines.
Mhm.
Sometimes a machine will work by its own, but in some other cases that we see often, they work as a group in a cluster. How do we handle this in JetScale AI?
Yeah, for sure. So just to clarify a little thing here, a cluster is a set of machines managed by another machine that scales up and down based on workload. So like any recommendation that we surface to customers, it's based on a whole variety of factors. So we have usage metrics, how resources are configured, how your resources are linked together, business requirements, and a whole slew of other things. So in the case of clusters, recommendations occur both at the top level, so on the cluster itself, and on all those child nodes that you have underlying that cluster. So a typical cluster, we would see a couple different types of recommendations. Some of the most common ones are moving from one type of machine to another. Another common one is moving from a bigger machine to a smaller machine. And all of this is just to make sure that what you're paying for fits your workload and you're not actually paying for more compute than you really need.
So what I see on the screen right now is I see that every child, there's a different recommendation and it's tailored for them. It's not just at the cluster level, right?
Exactly.
There's another word that I see a lot coming back in recommendation, and it's about spot instances. So please, can you explain me what's a spot instance and how do we recommend this and when in JetScale AI?
That's another good one. So I'm going to take a step back again. You usually have two different ways of serving virtual machines. You have on demand, and all the different cloud providers use different terminology, but essentially you have on demand and spot. So on demand is essentially guaranteed availability at a fixed price. So if you ask for an on-demand instance, it will always be there. But it's not always something you need, right? When it comes to spot instances, you can save, depending on the time of day, between 50 and 90% of the costs that you would be
huge.
paying. Exactly. No, it's a really big amount. But there's some caveats. So spot instances are completely dependent on availability. So they can be torn down, so essentially terminated pretty quickly. But that's fine if you're doing just development work, or maybe it's just a testing virtual machine or cluster. So it really depends on the workload going on. To figure that out, we usually check stuff like tags. So maybe this virtual machine is tagged as dev or test. In that case, you have more confidence to say, okay, you don't really need to be paying for guaranteed availability. And then in that case, we'd say, yeah, let's go spot. But also another big factor in that is all of those other data sources I talked about earlier, specifically usage metrics. So if you have an instance that's constantly idle, it doesn't really make sense to always be paying for that guaranteed availability if it's doing nothing 90% of the time. But on the other hand, if it has a constant workload running it, or we see that in the name or the tags, this is a production workload, then we'd usually stray away from actually recommending spot, because if you're serving customers, it's not great if your instances go down while somebody's trying to use your product.
Yeah, definitely. And it sounds like tags are very important as well, so that we can tailor recommendation even more and then bring significant cost reduction.
Oh, for sure. I mean, tagging is essential in cloud. It's helpful both for us to tailor recommendations, but even internally as a team. If you don't tag your instances, it's really hard to know why they exist. Some examples are you would usually tag to say whether this is a testing instance, a production instance, a dev instance. Also, you can add any number of different tags to describe what this particular resource is. And the more depth you give when it comes to tags, the better, just for everybody in general.
Yeah, that's very interesting. And you know that cloud is more than VMs. We discussed compute, but cloud is storage, right?
Yeah.
And storage can be very costly and not necessarily having the right type of storage for
Mhm.
your usage. Can you show us in JetScale AI some concrete recommendation about storage?
Yeah, for sure. I'll continue on the AWS side of things. So we have EBS volumes, which are essentially just storage attached to virtual machines. I'll go through some common cases again. The first is orphan storage. So this is essentially EBS volumes that exist after the virtual machine that was attached to it is gone. And this can happen for a variety of reasons, but it tends to be a common occurrence. And usually in that case, you obviously check the metrics to make sure and check the state to see if it's unattached. And at that point, usually you just want to delete it because it's not really doing anything for you anymore unless it has valuable data. But in that case, we'd also check if there's a snapshot of that EBS volume to make sure that you aren't actually losing any data when you delete the volume. Another case is moving from one type of EBS volume to another. So we all know the cloud is super complex and it's always evolving. So you may not be aware of a new type of storage that came out. And usually as the generations move forward, the new storage is cheaper. So it's in your best interest to move from an old version of storage. So let's say GP2 in this case to a newer version like GP3. And usually you get performance benefits too on top of your savings. There's also other types of storage that we could go through. Depending on your workload, you may not even need to have SSD backed storage like GP2 or GP3. Maybe you just need a hard disk because you're really not doing a lot of data transfer. There's not a lot of IO going on. And then on the other side of things, we have S3 buckets, which is general storage. In this case, it tends to get a bit more complex because there's a lot more surface area and there's a lot more to recommend. So to give a concrete example here, we have a pretty big bucket. This bucket has 21 terabytes worth of data. And we're recommending a couple different things. The first thing is adding an S3 endpoint. So this is a super easy win. It's completely free. And it essentially eliminates costs for data ingress and egress through your NAT gateways. And then on the other side of things, we're looking at enabling intelligent tiering and adding lifecycle rules. So really, when you have a bucket with this much data, you're not accessing all of the data with the same frequency. So based on the amount of days between access times on this different data, we would move them to different storage classes to save money.
There's one point you mentioned that I'm really curious about. You mentioned that moving from old storage or old machine to new machine, new storage, and there's something about extended support that clients pay for. Is this linked to this? And can you explain us how we can save money with that and with JetScale AI?
Yeah, so it's a similar idea. Essentially, when you put up a machine, you might have some sort of software backing it or running on it. And cloud providers will usually support version X to version Y over a span of time. But if you're outside of that range, you pay extra because you're the edge case now. Everybody's on the version range that is supported and you're behind. So you're paying extra for that extended support. And that can happen for a variety of reasons. First could be just general constraints. Maybe the migration overhead is just too great and you don't actually want to move on. And that's a super valid case for paying for extended support.
Because it's too risky.
Yeah, exactly. Another case is just you didn't stay up to date because it's super, like we said, cloud complexity. I don't know, you could have hundreds of resources running. It's hard to keep track of all of them. So maybe you did not bump the version on one of your machines or resources, and you just end up in that extended support area without actually being aware. So that's a very common case.
Thank you so much, Marwan, for all your insights today. Cloud is very complex. It's sometimes a mess too, but I think this was very clear to help us organize it and save significant amount of money with the platform of JetScale AI. So thank you so much for being here, Marwan.
Thanks for having me.
And thank you so much, everyone, for watching.